Welcome to a Melac online tutorial. Now let us look at this interesting exponential radical equation. And it read here that the square root of x all raised to 2x minus 1 equals to the cube root of x all raised to 6 minus x. We are requested to solve for x. Very easy. Now it's very important that whenever you encounter questions like this involving radical and exponent, the first thing first is to ensure to simplify the radical. So how do we do that? Now let's get started. First, let us take notes of some important law or rule in exponents. When you have the square root of x, in terms of exponent, this is x raised to 1 over 2. Okay, all right. And when you also have, let's say, a raised to m or raised to n, now this is same thing as saying a raised to the product of m and n. Okay, so let's just skip an eye of this rule. So let us get started. First and first is to implement this rule, okay, both on the left hand side and the right hand side. Okay, take note, in this case x is raised to 1 over 2, so we will apply that here. So in this case we have x raised to 1 all over 2 all raised to 2x minus 1 then equals x raised to 1 over 3 all raised to 6 minus x. Okay, so the next thing we need to do is to apply this rule, okay, where the two exponent, which is this, multiplies and this multiplies. Okay, so when 1 over 2 is distributed across these terms here, we end up having x raised to x minus 1 over 2, and that's because when these two multiplies, when 1 over 2 multiplies to x, now this 2 clears off this 2. Okay, and when half multiplies by 1, we are left with what? Half. Then equals, now we apply the same rule here. So 1 over 3 is distributed across 6 minus x, and that gives us x raised to 2 minus x all over 3. Okay, all right. So let us also recall that according to the law of indices, when you have a raised to m minus n, this is same thing as saying a raised to m minus all over a raised to n. And if you take a look at the equation, you can see this is similar and this is similar to this rule. So what do? We just apply that same rule. So here we have that this is x raised to x, then all over x raised to 1 over 2 equals x raised to 2, then all over x raised to x all over 3. Okay, so let's just cross multiply. By cross multiplying, I want to bring the x's together and the one without x's together. Okay, so by doing that, I have here x raised to x, then times x raised to x all over 3. Then on the right hand side, I have x raised to 2 times x raised to 1 over 2. Now by the law of multiplication, which is a raised to m times a raised to n, now this gives us a raised to m plus n. Now applying this rule to both the left hand side and the right hand side, now we get to have x raised to x plus x all over 3, then equals x raised to 2 plus 1 over 2. Okay, so if we are to simplify this, we end up having x raised to 3x plus x all over 3. Okay, then equals, simplifying this also, we have x raised to 4 plus 1 all over 2. The next thing we need to do here is x. Now 3x plus x will give us 4x. We have 4x all over 3, then equals x raised to 5 all over 2. Now a common mistake here is to equate the exponents, okay, which is ideal but not the proper way. All you just need to do here is to apply the ln, and the implication of equating the exponent at this point is you might end up not getting all the values of x. Okay, so all we just need to do now is to apply ln to both sides of the equation. So here we have that ln x raised to 4x all over 3, then equals ln x all raised to 5 all over 2. Now we need to apply the power log here. And what does the power log say? That when you have log a raised to n, now the exponent n becomes a multiplier to log a. Okay, if we apply that rule to both the left hand side and the right hand side, we end up having 4x all over 3, then ln x, then equals 5 all over 2 ln x. Okay, so all we just need to do to ensure that we clear the fraction is to multiply both sides of the equation by 6. And why am I multiplying by 6? Because I know 3 times 2 is 6. So by doing that, I have 6 here, then times 4x all over 3 ln x, then equals 6 also here, times 5 all over 2 ln x. Now by doing that, 3 here 1, 3 here 2, 3 here, 2 here 1, 2 here, then 3. So we are left with 8x ln x, then equals 15 ln x. So the next thing we just need to do here is to subtract 15 ln x from both sides. Now I have here 8x ln x minus 15 ln x, then equals, when I subtract 15 ln x from itself, it becomes what? 0. So at this point you will notice that I have the same term ln x. So all you just need to do is to factor out ln x from both sides. So by doing that, I have 8x minus 15. When I factor out, I have ln x equals 0. So at this point, since these two terms multiply to give us 0, so we can say ln x equals 0 for the first case, and 8x minus 15 equals the second case. Now for the first case, all I just need to do is to raise both sides of this equation by e for me to find the value of x. So by doing that, I have e raised to ln x, then equals e raised to what? 0. And why do I do this? So that I can clear off this ln x, which e will also clear that off. Then I have here x, then equals e raised to 0 is 1. So this is one of the solutions, okay, that satisfies the equation. And the next one here is this. So the next thing we just need to do here is to add 15 to both sides. So I end up having 8x, then equals 15. Now dividing both sides by 8. So this clears off this, then x equals 15 all over 8. Now this is the other solution of x that satisfies the equation. Please don't fail to share this video with other learners. Thank you and remain blessed. Bye bye.